Greetings. My name is Dr. Keren Obara, and I'm here to talk about the frontiers of the next level of artificial intelligence. So, we are talking about the trajectory of artificial intelligence, not just where the software is going, but also where the physical infrastructure is going. So, AI has evolved from a theoretical concept into the core backbone of modern innovation, modern society, and modern business. Powered by machine learning and foundational language models. But as demand explodes, we are rapidly approaching a wall. So this brings me to the bottleneck, which I call the constraint zone. If you look at the graph behind me, the problem becomes immediately clear. On one curve, we have exponential AI demand, and on the other, we have Earth's capability to produce infrastructure according to the demand. So, we have entered what we call the constraint zone. Traditional software and terrestrial hardware are hitting hard physical limits. Power grids are strained to their breaking point, cooling requirements are consuming massive resources, and ground-based data centers simply cannot scale fast enough according to the intense demand that we have. So this brings us to the terrestrial versus compute ideology. So we have industries, we have sectors, we have companies such as SpaceX that are already interested and acting into the concept of orbital data centers. So to understand why terrestrial compute could need an upgrade, we can compare earthbound data centers to orbital infrastructure. Here we go. So regarding the environment, ground centers are geographically constrained, plus low Earth orbit offers availability, however, also is restricted according and in comparison to sun synchronous orbit satellites. So when we come into power, Earth relies on constrained electrical grids, which are more constrained than the solar energy that can be gotten from sun synchronous orbit satellites. So when we get the aspect of cooling, we have a challenge that AI centers and data centers sort of press a challenge to humanity and to the environment through the excessive amount of water needed to cool them. So the takeaway is simple. Earth's infrastructure needs an upgrade in order to exponentially accommodate the future of AI compute. So we go to the surmounting the bottleneck. So we have two frameworks here, where versus how. So overcoming the bottleneck that we are facing as AI practitioners, we need to think beyond creating better algorithms, think beyond creating better codes, and thinking about a two-pronged shift. So where we compute. So if we are to expand further in the AI industry, we should think about bypassing physical limits by migrating compute software to orbital aspects such as satellites and etc. So how can we operationalize that? So we can take raw computational scale and funneling and direct it immediately to real-time tactical intelligence through sun synchronous orbit satellites. So here's where StarMind comes in. So SpaceX's StarMind is a planned mega constellation of up to 1 million satellites designed to operate as orbital data centers that process machine intelligence workloads in space. So what we talk about is how to make a congruence between the terrestrial data centers and the satellite orbital data centers. So this brings me to my hypothesis in regards to FCL Bloomtech Limited. What we do at FCL Bloomtech Limited is that we endeavor to combine two kinds of data and more data into our tools that we are providing. So using satellite data and agentic AI plus advanced general intelligence, we aim to provide effective solutions to make better decisions and to help our clients make better decisions through getting all the data that is lost in the supply chains and through the inefficiencies in the AI supply chain and computing all of that conglomerating all of that into data warehouses to provide these to the people that recognize our services and